Back to my channel. Here we are still working on plane figures with equal area, and we have another question here to solve that says that construct a regular hexagon in a circle of diameter 90 millimeters and reduce it to a square of the same area. I'll read the question again. Construct a regular hexagon in a circle of diameter 90 millimeters and reduce it to a square of the same area. All right, so let's go and construct the hexagon right now. So we are going to draw a horizontal line like this. Okay, so we draw a horizontal line, and then we take a measurement of 45 millimeters. If we divide 90 by 2, so that is 45 millimeters. So we take a measurement of 45, so this is 45 millimeters, and we put the pinpoint of the compass here on the line, and we turn it around to draw the circle of diameter 90 millimeters. So here we have the circle. Okay, so now, so let's call this point here, let's call it point A. So this is point A here, and then we call this point, we call it point G. Okay, so with the radius of the circle, so the same 45 millimeters that we used to draw this circle, so we put the pinpoint here at point A, and we draw an arc up, we draw an arc down. Okay, then we put the pinpoint here at point D, so we put the pinpoint at point D, so we draw an arc up and we draw an arc down. Okay, so we are going to label this point on the circle. So we have this point, this is point B, and then this point is point C here, and then we have this point to be point E. So this is point E here, and then this is point F. So we are going to join this point together to obtain the regular hexagon that we are asked to draw in a circle of diameter 90 millimeters. So we connect point A and B together, and we also connect point B and C together like this. Okay, then we connect point C and D together with a straight line to have this side of the hexagon, and then we also connect point D and E together. Okay, so we have side DE of the hexagon, and we also connect EF together with a straight line to have side EF of the hexagon, and then we connect this side, these 2 points together, A and F together, to get side FA of the hexagon. So here we have the regular hexagon that we're asked to construct. Now, we are going to, for us to get the square that will be equal in area to this hexagon, there are other things that we need to do. We need to construct a triangle that is equal in area to this hexagon. Then we construct a rectangle that is equal in area to the triangle. Then we'll now go and construct a square that is equal in area to that rectangle. So let's see how we are going to do this. We start with that of the construction of a triangle that is equal in area to this hexagon. So what we have to do is that we are going to join this point F with point C, or we join point F with point B, any of the two, and then we join point E with point C, or we join it with point B. So we are choosing either this or this. Okay, but we are joining F with either of them, and we are joining E with either of them, but I choose to make use of point C. So I will draw a line from F to point C, and I will also draw a line from E to point C like this. So I have this. Okay, all right, so we have this now. Then the next thing that we are going to do to draw that triangle that is equal in area to this hexagon is that we are going to draw a horizontal line. We need to extend this horizontal line at the base of the hexagon. So we extend it to this side. We also extend it to this side like this. And then, so we take our set square. We are going to draw a line at point A that is parallel to line CF. Okay, so that's what we are going to do now. So we take the set square and we are going to set the set square along this line CF. So we set along line CF and we put the ruler under it. So we put the ruler under it like this. Okay, then we shift the ruler to point C here, and then we draw a line. So we draw a line, so from A to this line on this horizontal line. So I'm going to call this point, I'll call it point G. So this is point G here, and this line AG, so this line AG is parallel to line CF. So it's parallel to line CF. We have to show that. And then the next thing that we are going to do is that we are going to draw a line at point D here, okay, that will touch this horizontal line, and that line will be parallel to this line CE. So we also need to set the set square along this line like this. So we set the set square along this line, okay. Then so we shift the set square, so we shift it to point D, and then we draw a line from D to touch this horizontal line. So here we have point H here, so this is H here, okay. Then this line DH is parallel to line CE as we have here. So all right, so now let's draw the triangle that is equal in area to this hexagon. So what we have to do is that we are joining these points, point G, we join it together with point C. So we join together with point C, and then we also join this point H here. We join it together with point C. So we have this, okay. So we have this now. So the triangle that is equal in area to the hexagon ABCDEF is triangle DCH. Triangle DCH is equal in area to this hexagon. Now, so having done that, the next thing that we are going to do is to draw a rectangle that's equal in area to this triangle GCH, okay. So to do that, we need to draw a perpendicular down from point C down to touch this line GH. And if you look at it, this line CE is a perpendicular line, is a vertical line. If you look at it very well, it's a vertical line. So that has been taken away. What we have to do now is that we are going to bisect this line CE. We bisect this line CE. So to do that, we need to make use of our compass. So we put the pinpoint of the compass here at point C, and we extend to a radius a little bit more than half of the line, more than half of the line. So we are going to draw an arc to this side here. I will draw an arc to this side like this, okay. Then I will put the pinpoint here at point E and also draw an arc like this, and then I will draw an arc like this. So if you look at this arc that we have here, I'm looking at it that it passed through this horizontal line, so which is the middle of the whole okay, which is the diameter of the circle that we used to construct this hexagon. So I don't have to draw horizontal line again. I don't have to draw horizontal line again. Normally, I want to draw horizontal line that will pass through the center of the of the arcs, so that we have that to be the length of the rectangle. So with what I have here, I already have a horizontal line, so like this, okay. All right, so then the next thing that we are going to do to draw the rectangle that is equal in area to this triangle GCH is that, so from this point D here, we draw a vertical line, so to touch the horizontal line. So looking at this now, so this is a side, so this line DH, so which is the vertical line, is a side of the rectangle. So all I have to do is to come to point A now, and also draw a vertical line from here. So draw a vertical line from here to touch, okay. All right, okay, sorry. So this line is not the one that we are going to use. We are not using this line. We are using what the length of the rectangle is GH. The length of the rectangle is GH, not this A. So I'm sorry for that. So it's an error. So I'm going to extend this line. I have to extend this line. So I'm now going to draw a vertical line from point G to touch this line, okay. So looking at what we have here, so I'm going to call this line, so I'm going to call this one, this is point I. So the rectangle that is equal in area to triangle GCH is rectangle GHDI. GHDI is the rectangle that is equal in area to this triangle GCH. And do not forget that triangle GCH is equal in area to the given hexagon ABCDE. Now, having done this, now we are now going to construct a triangle, a square that is equal in area to this rectangle, and that will also be equal in area to the triangle, okay. It will also be equal in area to the hexagon. What I mean is that we are going to construct a square that will be equal in area to this rectangle, okay, then to be equal in area to this triangle, and also be equal in area to the given hexagon ABCDEF. Okay, so let's take note of that. So what we are to do to draw that square now is that we are going to extend this line a bit to this side. So I want us to have it outside here. So we are now going to take compass. So putting the pinpoint of compass here at point H here, I will extend it to D. So then I'm going to draw an arc like this. So we draw an arc. Okay, we draw an arc here. So meeting this horizontal line at this point. So I'm going to put this point. I will call it point J. So this is point J here. Okay, so having done that, we are now going to bisect distance GJ, bisect distance GJ. That is what we are going to do. So we put the pinpoint of the compass here at point G. Okay, put the pinpoint here at point G. Okay, so then we are going to draw an arc. So we draw an arc down here and we also draw it up here. Okay, like this. And then we put it at point J here. Okay, so we put at point J. So we are going to draw an arc like this. So this is this cannot work. So I'm going to, so I need to extend it more. So I need to extend. So we are not going to use this arc now. So I need to make it to be more than that. So I need to draw an arc like this and also draw an arc up like this. So I'll be taking it to point J now. Okay, so and then I will draw an arc here. So draw an arc here. So the point of intersection of the arcs that we have here, so this point and this point, so we are going to join them together. So we join this together like this. Okay, we join the point of intersection. Okay, all right, so this is the point. So this point and this point are the point of intersection of the arcs. So so we draw a vertical line like this. Okay, we draw, that is bisector of a line GJ. Okay, so now, so we locate a point. So there is a, this is the midpoint. This point is the midpoint of line GJ. So I will call this point, let's call it point X here. So what I'm going to do now is that we are going to draw a semicircle to this point GJ. So we put midpoint of the compass here at point X and we extend it to J here. So we extend it to J. Okay, then we turn it like this and draw a semicircle on GJ, on point GJ. So this is the semicircle. All right, so we have this semicircle like this. Okay, so the next thing that we are going to do is that we are going to extend this line DH to touch the semicircle and it goes like this. So I'm going to use a thick line at once. Okay, so I'm going to use okay, so it goes like this. So it touches, okay, it touches the semicircle at this point. So I'm going to call this point, this is point K here. Okay, so this is point K. So this line KH, this line KH is a side of the square that will be equal in area to the given hexagon. So for us to now draw the hexagon fully, so you take this length KH of the square. Okay, so take this distance. Okay, so pinpoint at H as we have here, then make an arc on this line. So make an arc on this line here. So this point, so is so this is point L here. So with the same radius, put it at this point L and make an arc up here. So make an arc up here. Okay, then with the same radius of KH, so put at this point K here and make an arc here. So here we have what? So HIGKL. So this is M, this is point M here. So we have this to the point M. So we are going to form the square now by joining. So this point L and M together with a straight line like this. Okay, then we also join point KM and together. So point K and M together. So we have this. Okay, so this gives us a square that is equal in area to the given hexagon. That is equal in area to the given hexagon, and also this square is equal in area to the rectangle that we constructed, and also to also be equal in area to the triangle that we constructed. So it's as simple as I've done it here. All you have to do is to practice. When you practice this, become a master at this work. Thank you. Keep on practicing and God bless you.